Hey guys, this video is to explain Project Task 9, and if you open up the instruction sheet, you should be looking at this document. It would be page 15 of it. So in Task 9, is there a relationship between height and foot length? Let's start with our Google Sheets file and our Chapter 9 notes open, and then let's add one new worksheet to the Google Sheets file, and let's name it Task 9. So let's go over here, let's hit that plus sign. We've added a new sheet. I'm going to rename it Task 9. All right, so now that I've done that, I need to go into the first state that I was assigned for in Task 7. Copy paste column H for height and into column A, and column I, which has foot length, into column B. So remember, you were all assigned states. I back in Task 7 did Tennessee and Virginia. Whatever your first state was. Now, I don't want to analyze the Tennessee data in this particular video because that would be an unfair advantage to anybody who had Tennessee as their first state. So I'm just going to go grab you guys. Actually, changed my mind. I'll just stick with the instructions. Tennessee, let's go grab column H, where I see height, and column I, where I see foot length. Let's do a copy. And into our Task 9 sheet, a paste. Okay, so up to step 4, I have to look for errors that seem like mistakes or left out stuff. Survey takers don't always follow instructions or measure correctly, so I'm going to have to go row by row through here. First, I'm noticing in row 4 that it's empty, so I'm going to delete row 4. Now, I see somebody who recorded their height as 83 centimeters. That doesn't sound right to me. That sounds way too low. Not sure what they must have been doing, but I'm going to ask Siri. Convert 83 centimeters to inches.
32.68 inches.
Okay, so these were high school seniors who were taking this survey. To record your height as 83 centimeters or 32 inches, it makes no sense. So I'm just going to go and delete that row. Next, I see a 5 foot 10 inches. So that person wasn't paying attention. I'll ask Siri again. Hey Siri, convert 5 feet 10 inches to centimeters.
5 feet 10 inches is equivalent to about 178 centimeters.
Okay, so Siri told me to put 178 in there. I see now a 58 for height. There's, again, no reason that makes sense, so I'll have to delete that. Wow, a lot of bad measurement takers in the state of Tennessee. Delete that. Row 12 now. If somebody left their foot length blank, that ruins the paired data, so I have to delete row 12. Another person who recorded their height is only 83 centimeters. Totally doesn't make sense. Another blank row. Okay, so I've cleaned up the data, again, using my discretion, my own judgment, for making sense that people took seriously the height and foot length measurements. Again, these are high school seniors, so now I'm looking and these numbers make sense to me. Okay, so I'm up to instruction 6. I'm clicking column A and column B, and I'm going to go Insert, Chart, and the chart that pops up, for some reason, I don't know why Google would default to a histogram, but this isn't what we'd want. Let me give you more room to see this. So also what pops up is a chart editor. So instead of histogram for chart type, let's scroll down and pick scatterplot. Okay. For the x-axis, we see height in centimeters. Okay, and the y-axis is foot length. That's how we wanted it. We're using height to try to predict foot length. Everybody is using height as the explanatory variable and foot length as the response variable. Okay, so that was that instruction. So if we wanted to put axis titles in, that's instruction number 6. If we go in here under chart and axis titles for the Customize tab, chart and axis titles. Chart title, we don't want it to say histogram, so let's fix this to scatter plot of foot length versus height. Okay, under horizontal axis title, so height cm was the variable name. Usually you might see it, more formally, just height, and then in parentheses what the units of measure are on the horizontal axis title. Let's go to the vertical axis title. Technically, foot length would be 2 words. Whoops, I don't know what I'm doing here, sorry. Foot, L-E-N-G-T-H, units are centimeters. If I X out of here, I now have a more reasonable scatter plot. Okay. Other thing I might notice, if I did want more customization, and these aren't in my instructions, but I feel like we should have had a broken y-axis. Google only broke the x-axis. Let's go break the y-axis as well. So back to double click, customize. Let's go to series, I think it is. Nope, the horizontal axis. Instead of letting the scale factor be default, and let's go from we want this on the vertical axis. Vertical axis, I'm on the wrong tab. Vertical axis, looks like we should just go from 20 to 40? And what that allows us to do is see the relationship a little bit more clear so that the data is not all squished together. Okay, probably would have been fine to do 20 to 35. So if I keep fixing that, let's remember where I was again. The Customize tab. I was on the vertical axis. Don't really need to see all the way up to 40. So let's go 20 to 35. And then it decided to count by 5s. That's fine. If I wanted a different scale factor, I could pick something different, but we'll leave that on the default. Oops. What happened there? There we go. I accidentally clicked there. Okay, so I'm happy with my scatter plot. Let's go to the next instruction. Let's describe the scatter plot: form, direction, and strength. Clearly, I don't see curvature, so I'm going to go for form, I'll say linear. For direction, positive. And for strength, it looks moderately strong. So moderately strong positive linear relationship. Now let's go actually quantify that correlation that I see. So here's the instruction right here, next to number 8. We want to go into cells D1 and E1. So let's go to D1 and just type the word correlation. And E1, let's equals CORREL, open parentheses, the data is in A2 to A16, and then a comma, and then B2, this is the 2 dot colon for the cell range to B16. Close those parentheses, hit enter, and yeah, we got pretty moderate positive correlation at 0.75. Okay, next instruction. Interpret that correlation. You can, read notes and find the sentence that will interpret that for you. Also in the notes, I would like you to test for significant linear correlation. I'm directing you to page 9 of those chapter 9 notes, which shows you how to work out the t-test from this R value, because I'm not expecting you to go type this data into your calculator. If you go from the page 9 instructions, you can use just that R value to get the t-test carried out. Okay, now let's go back and double click in the scatter plot. Let's open that chart editor and let's get the scatter plot to put the so-called regression line and regression line equation. So back over here, if we double click, the chart editor pops open again. Let's go in the Customize tab, and we told you to select the word series. And down here, you'll see a checkbox for trend line. And then you'll see one more label to pick use equation. Okay, so here we go, X out of there. Now we have the line of best fit displayed on the scatter plot along with the equation that says if you want to predict foot length, you will take the height, which is X, multiply by 0.225, and looks like the y-intercept came out to negative 14.5. Okay, well, y-intercepts can come out negative. We know that we don't need negatives on our y-axis, but that's apparently where the y-intercept would be if we were to extend this out. Notice that's extrapolation. We don't have any x values or heights anywhere near 0, so we kind of have a meaningless y-intercept, but that's besides the point. What is important to me is the slope of 0.225. So I'm going to write that equation down, and now interpreting slope. This is what's important to me, the 0.225. So I'm going to know that if anyone's height goes up by 1 centimeter, the foot length will also go up by 0.225 centimeters. So essentially then, for everybody's height, if we went with a 10 centimeter increase in height, we'd have a 2.25 centimeter increase in foot length. That should be explained over here. And then finally, what else are models for besides interpreting slope? They're for making predictions. So if I tell you my height was 164 centimeters, predict my foot length, you're going to go into the equation, you're going to substitute 164 for that x and predict foot length. Remember everybody, you all have different data sets with different scatter plots and different correlations. This should be for whatever state I gave you as your first state back in task 7. Okay, so please scan your page, whether you printed this worksheet and worked on it or whether you just wrote this workout for these questions on a sheet of paper. Please scan and upload to my essay, and that completes task 9.